Hello guys and welcome to AlgoCraft. Today we are solving the lead code problem number 232. Implement queues using stack. So first I will read the question, then we will dive into my approach, and then I will type code in front of you. So the question says that implement the first in first out FIFO queues using only two stacks. Means the question is saying that we have to make two stack and we have to make stack something like queues. So the implemented queues should support all the function of normal queues: push, peek, pop, and empty. Implement the myQueue class. Okay, this information is given. So now let's dive into my approach, then you will understand it better. So now let's understand the problem statement correctly and we'll dive into our approach. So for understand the problem statement correctly, let's dive into our whiteboard to understand the problem. Then we have to achieve the nature of queue using stack. So we have to do push, pop, pick in stack, and we have to achieve the nature of queue. So how queue works? So if I put 10 in queue, okay, so first I will make a queue. So first element is 10, so I push 10 over here in our queue. Then the another element is 20, so I push 20 in our queue. Then the another element, suppose 30, so we'll push 30 in our queue. So if we pop our queue, so first the 10 will be removed, then 20 will be removed, then 30 will be removed. And in stack, if I put 10 over here, then I put 20, and then I put 30. So first 30 will be removed, then 20, then 10. So it is opposite of our queue. So the queue works on first in first out data structure. So if I entered 10 at first position, then at first, so if I enter 10 at first, so the first out will be our 10, and the stack works on last in first out LIFO data structure. So if I put any element at the last of the stack, so if I pop this element, then 30 will be removed at first. So now let's understand how we have to solve this question and what we will our approach. So the question has first said that we have to use two stacks. So we'll make two stacks. This is our first stack. This is our second stack. We'll name it I and we'll name it help. For example, we are naming it this. Okay. Now we'll make our queue over here. This is our queue and this both is our stack. Okay. So now if we have our element 10, so let's suppose we put 10 over here in our queue at first position. So we put 10 and we have to put 10 in our I stack also. If we put any element in our queue, so we have to put this in our stack also. Okay. So okay. Now we push 20 in our queue. So we have to pop our elements from I to helper. We have to transfer our element from I to helper to make a relation between both of them. Okay. So now 10 is not available in our I. Then we'll put this 20 at the I. Okay. Now after that we'll put this 10 in our I again. So now see what happened. If we push 10 from, if we pop elements from queue, so first this 10 will be removed, and if we pop elements from stack, then here also 10 is removed, then 20 and then 20. So we are achieving our relation. Okay, you understand? We are achieving our things what question said. So now suppose here comes 30. So what we'll do is we'll pop all the elements from I and place in our helper stack. We'll pop this element and put it over here. So now we have 20 and 10 in our helper stack. Then we'll push this 30 in our I. We have pushed our 30 in our I. Then after pushing this, we'll just pop elements from our helper and place in our I. So we will achieve our nature. So now we pop our elements from helper. So you can see that if we pop from the queue, then here 10 will be removed first, then in second position 20 and then 30. Here we can see that stack 10 is removed, then 20 and then 30. So we are achieving our nature. Okay, so this goes something like this. If I put 40 over here, so this will also appear something like this. So we have to put 40 over here, and 30, 20 and 10 over here, because we transfer all the elements to the helper. Then after I push 40 over here. Okay, so now let's dive into our code. I will code in front of you so you will understand it more properly. First we will make a private stack variable. We will name it main, which is our I in our example. We will copy it and we will make another stack which we will name it as helper stack. Then in our main function we will declare this stack. So main is equals to new stack. So now we have declared this stack, and then we'll name another stack as helper stack. So now our both stack is declared. Now we will push element in our stack. Okay, so how we have to push that? So we will check the condition that while main dot size is equals to 0. So first we will pop out all the elements. From main stack, and we will transfer the elements to the helper stack. So what we will do is main helper dot push, and what we have to push, what we have popped from main. So we'll do main dot pop over here, then push our element in our main stack. So now we have pushed our element from our main stack. Then we'll run the while loop again, which will transfer all the elements from helper to main. So I will do helper dot size is greater than 0. If the helper of size is greater than 0, then what we have to do? We have to push all the elements from helper to main. So we'll pop the elements from helper and push it in our main stack. So here we have to now declare our pop function. So I'll do main dot pop. We'll just write only this one line, main dot pop, which will return our popped element. Now we'll do main dot peek, which will return our first element, which is present in our main. Now we'll return that main is empty or not. If it is empty, then it will return true. If it is not empty, then it will return false. So I forgot to put return statement over here. Okay, so what we have to push, we have to push X in our main stack. Now we'll again run our code. Okay, our test case is accepting. Now we'll submit our code. Okay, my code is submitting properly. So if you like our video, please like, share, subscribe to the channel, and if you have any query, please comment down below.